All right, so if you look at this thing, we jumped to chapter 12. We were on chapter 7, okay? We jumped all the way to the end. This is the very last chapter of the book. All right, it's chapter 12. Oops, I did something here. I accidentally started that program. I want to close it down. There we go. All right. Well, I thought I closed it down. That doesn't matter. Okay. So this is just something that I just think it's so important. I do this every year with my geometry, even if we haven't gotten all the way to chapter 12. All right, I think the furthest I've ever gotten is like maybe chapter 8 or 9, maybe in an honors class. But I always jump to chapter 12 because I think this is so important. You're going to see this if you take higher math. If you take Algebra 2 next year, you'll see it. If you go beyond that into pre-calculus, you'll see this stuff and beyond. All right, so I'm just giving you a little bit of taste, just a little bit of taste of what this is about. Okay, we're only going to do 2 lessons. We're going to do 12.1 and 12.2. So it's just to get you it's maybe a foundation, I guess you could say that. All right, I just want you to understand what trig is about, at least a little bit of it. All right, we're just getting started. So I use that word trig. Okay, trig is a word that math people use to shorten this big long word right here. It's trigonometry. So that's the study of angles. I think it's the study of angles. I used to say it's the study of triangles, but I think trigonometry really means the study of angles. You can look it up. I don't know. It doesn't matter, but that's what it means. We're dealing with angles. We're dealing with angles in triangles. We deal with triangles a lot in trigonometry, but we shorten it. Instead of saying trigonometry every single time, what do we say? Trig. All right, so we just say trig, but it's short for trigonometry. All right. It used to be, way back in the day, high school classes would have a class just on trigonometry, right? So you take whatever. You take your Algebra 2s, you take whatever, and then they have a trigonometry class. It seems like nobody does that anymore. Even in colleges, I don't think they have a class actually called trigonometry. It's usually incorporated into other things. So they've incorporated just a little bit in geometry, in Algebra 2, in pre-calc. So right now, as we're talking, I'm teaching trig to all of my math classes. So I teach 4 math classes to get all together. So all my math classes right now are doing trig, which it's hard. Sometimes it's hard for me to keep track of what I've done in one class compared to another class. But that's what we're doing in here. I think it's important. You're not going to have a complete full understanding by any stretch of trig, but at least you'll get a little peek through the window of trigonometry. All right. So trigonometry, the stuff that we're going to do right now, not all trigonometry, but what we're going to do right now only deals with right triangles. All right, so let's draw a right triangle. Makes sense, doesn't it? So what we are doing in here only deals with right triangles. Now, the further you go in this chapter, again, we're at the end of the school, so we only got 2 days, two lessons. But if you go on to the end of the chapter, you will be doing triangles that are not right triangles. But for right now, we're just going to learn some basic, what do they call these? Trigonometric. That's a crazy word, right? Just talking about the trig ratios, all right? Trigonometric ratios. By the way, what do we talk about when we talk about a ratio? It's not really a sum. Like a lot of times you'll see a ratio written like this, 3 like colon 2 or 5 colon 7. You ever see that? Like when people do bets and stuff like that, they say the odds are 3-2 or 5-7 or something like that, okay? This is basically, you could rewrite this. You've done this before, right? Maybe in like middle school, you probably talked about ratios. You ever see that? The colon stuff? All right, what's another way we could write it? Instead of the colon, what's another way we could write it? As a what? Fraction. Good. All right, and you could write this as a fraction. Agreed? All right, so basically, what is a ratio then? It's a what? It's a fraction, right? It's a comparison. We compare one thing to another. That's what a fraction is doing, all right? Like half. Let's say you ate half a pizza. What are you doing? You're comparing one part of it to the whole thing. You want to get the door? Yes. Tomorrow? Okay.
First, fifth, and last.
Okay. Yeah, I might get Sam to go in there and shoot those. Thank you. All right, so it's a comparison, okay? We're comparing something, okay? We're comparing one slice to two slices or whatever, okay? So that's what we're doing. So let's deal with this. Let's call this A and B and C. Yeah, that's good enough, okay? Let's put some numbers in here too, all right? Well, we're gonna make this really easy. I'm gonna pick a Pythagorean triple, all right, just to make it a little easier for us to deal with. So I'll call this 3, I'll call this 4. What's this gonna be? It's gonna be 5, okay? It's one of our Pythagorean triples, just to make it kind of easy for us. So many interruptions.
Teacher, sorry for interruption with the following students. Please go to the sanctuary. Leona, Kaylee Thomas, Gail Wilson, Noah Thomas, Ethan Kiley, Autumn Krastowski, Casey Chambers, Penny Velez. Thank you.
All right. Okay, so this is recording, yes. All right, so what do I want to do with this? What I'm going to do is I'm going to make a comparison. I'm going to make a ratio. I'm going to make a fraction. I'm going to make a comparison between one side and another side. Like I'm going to compare the 3 to the 4, the 3 to the 5, the 4 to the 5. Okay, I'm going to make certain comparisons. And those particular comparisons have a word associated with each one of those comparisons. With each one of those ratios, right? That's what a ratio is, a comparison. I'm going to compare one side to the other. So I've got 3 basic ones. There's 3 other ones, but we're not going to do those today. We probably won't ever do those in this year anyway. But there's 3 basic Okay. So there's 3 basic comparisons that we're going to do. And we have certain words. These words you probably never heard of before in this context anyway, all right? We got 3 words that describe a comparison between one side and the other side. Before we do that, I want to look at this. This really depends on which angle that we're talking about. So I'm going to write this in another color. So if I'm dealing with angle B, I'll put that in yellow, all right? If I'm dealing with angle B, what is side 3 in comparison to this angle? It's across from it. It's not perpendicular. There's no parallel line. You're just throwing out geometry words that you've heard before. You're not even thinking. Okay, it's across from it, but we don't use that word across. We've talked about this a lot this year. It's not across from it, it's opposite, okay? So side 3 is opposite angle B. Would you agree with that? I'm going to write the word opposite right here. Actually, I'm going to shorten it. I'm just going to put the first 3 letters, okay? So this is opposite. What is this side 4 to this angle B? We've talked about this. I think we have. Maybe not. This is called adjacent. Okay? Yeah, we've talked about that word adjacent, haven't we? Yeah. This side, well, we're going to talk about it now. So this side right here is adjacent to or next to, right? So if I say I live adjacent to Wawa or whatever, okay? What does that mean? It means I live next to that particular thing, okay, whatever it is, okay? Or to my neighbor, right? I live adjacent to my neighbor. That means next to, right? You understand why it's next to it? Because it's connected, right, to that angle right there. See, this side is connected. This side opposite is not connected to that angle. Would you agree? All right, this is opposite, completely opposite. This is adjacent. Now, what is the 5 always going to be? I mean, technically it is adjacent to this, but this is the hypotenuse. Good. Okay? So that's the hypotenuse. Why is it the hypotenuse? How do I know that that's the hypotenuse? Because it's what? It's not because it's the longest side. Now, it is the longest side. It's opposite the right angle. That's why it's the hypotenuse. Okay? Everybody understand that? Because you can have a longest side and it not be the hypotenuse. Because what if we had a triangle that didn't have a right angle? Then I don't have a hypotenuse, do I? But I still could have a longer side. Okay, so the hypotenuse is opposite the right angle. So it's important to understand that. Now, that's dealing with angle B. What if I was dealing with angle A? I'll put 2 arcs right there. I'll make it blue too. It's kind of separated. So now this side 4 is not going to be adjacent to angle A. What is this side 4 going to be to angle A? It's going to be opposite. That's right. And I color coded them so you could see. All right. Does that make sense? So this side right here is not always going to be adjacent. It all depends on which angle that you're dealing with. All right. If I'm dealing with angle A, then this side is opposite angle A. What is this opposite, or what is this side 3 right here? This would be adjacent. That's right. This would be adjacent to what? To angle A. All right. So it all depends on which angle that you're talking about. What about the 5 to angle A? This is already adjacent. It's still the hypotenuse. It doesn't change, does it? Hypotenuse is always the hypotenuse. Why? Because it's always opposite the right angle. So it doesn't matter what angle I'm dealing with, 5 is always going to be the hypotenuse. That's super important for what we're going to do here in a little bit. Okay? So what I'm going to do, I've got 3 words. Okay? 3 words that we use in trig that describe 3 relationships, 3 ratios, 3 comparisons, right, of one side to another side. So what I'm going to do, I need a word that shows the relationship between, or the comparison, or the ratio between the opposite side and the hypotenuse. Okay? There's a word. You're going to see it just in a matter of like a minute. All right? There's a word that compares the opposite side to the hypotenuse. There's also a word that compares the adjacent side to the hypotenuse. And then there's another word that compares the opposite side to the adjacent. So instead of saying that all the time, instead of saying, I'm comparing the opposite to the hypotenuse, okay, from angle B, instead of saying that, that's a lot to say. We have 3 words that sum all that up in one little word, okay? All right, and I'm going to show you those words right now. Bet you can't wait. So the first word is the sign, all right? It's S-I-N-E. It's not like a road sign, S-I-G-N. It's S-I-N-E. You've probably never seen it spelled like that before, okay? So, but we shorten it, all right? We shorten it to S-I-N. We just use the first 3 letters, all right? Now, it all depends on which one is opposite and which one is adjacent. All depends what angle you're dealing with. Would you agree? Yeah. So let's do the blue ones. We'll do A first, all right? So the sine of angle A. Now, here's the relationship. This is the first time. I mentioned 3 of them, but I didn't tell you which one is which. So the word sine is just a word, okay, that describes the opposite side over the hypotenuse. Those are the 2 things that I'm comparing. The opposite side to the hypotenuse. All right, so I'm going to write that. I'm going to write it right here. Opposite to the hypotenuse. Okay? Now, let's put some numbers in here. So if I'm dealing with angle A right here, you know what I should do? Since I'm dealing with angle A, let's make all this blue. We'll keep it color coordinated here. Is that all right? So I'm dealing with angle A. I made that blue, so I'll make all this blue. So what numbers am I going to put in here? The sine of angle A. What does the sine mean? It means just take the ratio of the opposite side to the hypotenuse. So which one is opposite angle A? 4. Which one is the hypotenuse? It's 5. So if I asked you, if I gave you that triangle and I said, what is the sine of angle A? What would you tell me? 4 over 5. Okay? Again, what does that word sine mean? Because a lot of students get right. It means you're taking the relationship or the ratio of the opposite side to the hypotenuse from angle A. Instead of saying all that, that's a lot to say, isn't it? So all I got to say, it's kind of like a little code word. All I got to say is take the sine of A, sine of angle A, right? So instead of saying take the ratio of the opposite side divided by the hypotenuse of angle A, that's a lot to say. So all I got to say now is find the sine of A. Make sense? Okay. Let's do another one. So that's the first one, opposite over hypotenuse. Let's do another one. It's called, let me write down the word first. It's called the cosine. Cosine. Again, we just use the first 3 letters, C-O-S. We don't say cos right here. We don't say sin. We say what? Cosine, and we say sine. Okay, so don't say sin, don't say cos. All right, it's cosine and sine. So again, it all depends what angle I'm talking about, and I'll show you in a bit. The cosine of angle A is the adjacent side over the hypotenuse. Okay, so that's what everybody agrees on, that the cosine means you take that angle, you take the adjacent side divided by the hypotenuse. What is the adjacent side to angle A? 3, right there. So I put 3. What's the hypotenuse? It's 5. So if I asked you what is the cosine of angle A, what would you tell me? 3 over 5. Simple. Does that make sense? Okay, we got another word. And that word is tangent. How do you think we shorten that one? Tan, T-A-N. But we don't say tan. We say what? We say tangent. We say tangent, right. And I'm gonna stick with angle A. Now, here's the relationship. You didn't know it? Here it is. It's the opposite side divided by the adjacent side. The fraction is your answer, right. If I just say what is the sine of that angle, that is the answer, correct. Okay? Because what is the sign asking you? It's asking for the ratio of one side over another, the opposite over the hypotenuse, right? It's just asking for a fraction is what it's asking for. Does that make sense? The cosine is just asking for a fraction. It's saying, it's asking you, what is the adjacent side divided by the hypotenuse? That's what cosine means. What does the tangent mean? It means find the opposite side and divide it by the adjacent side. Okay, opposite over adjacent. Let's do that. What's the tangent of angle A? Opposite, 3 over adjacent, 4. So it's 3 over 4. Everybody see that? Now, I could ask you to just memorize that. Just memorize that. Just memorize that. All right, I could, but there's a little trick. A little thing we call a mnemonic device. We actually do a mnemonic device. Maybe you've heard of that word, maybe you haven't heard of that word, okay? What that word means, it's like when you take a bunch of letters, you put it together and it kind of sounds like a word, but it's really not, but they all stand for something. For instance, we've done that in math already. Do you remember PEMDAS? Okay, what is PEMDAS? Yeah, parentheses, exponents, multiplication, division, addition, subtraction, okay? Mario. I just told you. Oh, my goodness, you're right. Thank you. That's right, very good call. Okay, the opposite is 4, okay, and the adjacent is 3. Thanks for that. All right? Glad you caught me. All right, so a mnemonic device. It's like, please excuse my dear Aunt Sally. Remember that? All right, or PEMDAS. All right. We have one for this as well. So let me show you where it comes from. The sine, I'm just going to write S for sine, equals the what over the what? The opposite over the hypotenuse, okay? Let's do the cosine. The cosine is what over what? Adjacent over hypotenuse. I'm just going to use A for adjacent, H for hypotenuse this time. I'll show you why in a second. Now the tangent. What's the tangent? Opposite over adjacent, so it's O over A. Okay? Now watch. You could memorize that. That's fine. But here's a little easier way to memorize it. You watching? This is the first time. This is something that's like super famous. Okay? For anybody doing trig, this is like one of the first things you ever learn. So it's SOH. Why did I write it like that? Just because I can say so. That's how I would pronounce it. SOH is so. And then what is the C? C-A-H is ka. All right. And then T is what? Toa. That's it. You got it. So we say SOHCAHTOA or just SOHCAHTOA. All right. If you go to anybody that's had me this year, okay, anybody that's had me in a math class this year, and you go up to them and you say SOHCAHTOA, they'll know exactly what you're talking about. It's the trig ratios. So let's go through it. Let's push this all up and see if we understand what that means. If I say so, let's say it together. Let's say SOHCAHTOA. On the count of three, we're going to say it together, all right? We're going to say SOHCAHTOA. Ready? 1, 2, 3. SOHCAHTOA. Yeah, perfect. SOHCAHTOA. SOHCAHTOA. Everybody say it again. SOHCAHTOA. 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 All right. How does that help us? Because when I hear the SO, I'm thinking SOH, right? Which means sine is what? Opposite over hypotenuse. Even though I didn't write it over right here, that's what you should remember, okay? What is the ka? What is that? The cosine is adjacent over hypotenuse. And the T is tangent is opposite over adjacent, all right? So that's a nice, easy way that we can remember the sine, cosine, and tangent, all right? Make sense? Let's go back to this. Let's put in a different color. Let's go to this pink color. On the blue ones, I did the sine of A. Let's stick with yellow since we put these in yellow. What I want to do now, what do you think? I did the sine of A, cosine of A, tangent of A. What do you think I'm going to do now? Sine of angle B, and then I'm going to do the cosine of angle B, and then I'm going to do the tangent of angle B. Okay? Everybody with me? So let's come to this triangle. What angle am I dealing with right now? Angle what? Angle B. So this is the angle right here that I want to look at. So the sine, without looking up here, just in your head, sine is what? What over what? Opposite over hypotenuse, okay? So now let's look at the triangle. And what is the opposite side of angle B? What number? Give me a number. Give me a number. It's 3. That's the opposite, okay? So it's 3 over the hypotenuse. What's the hypotenuse? 5. What's the cosine? Again, in your head. Close your eyes. In your head, what's cosine? Cosine's what over what? It's adjacent over hypotenuse. Very good. So open your eyes again. Look up here. What is the adjacent side to angle B? It's 4 over 5. Good. Okay. What's the TOA? The tangent? Opposite over adjacent. So take that angle. Which one's opposite angle B? 3. And which one's adjacent to angle B? 4. Everybody see that? All right. So now watch. Taking the sine of angle A is a lot different than the sine of angle B, isn't it? All right. Sine of A is 4/5. The sine of B is 3/5. But check this out. It's kind of interesting. I'm not going to harp on this too long, but watch. The sine of angle B is the same exact thing as what? The cosine of angle A. Do you see that? So the sine of B and the cosine of A are the exact same thing. What else do you see similar? Sine of A and the cosine of B are exactly the same thing. Look at the tangent. Look at the difference between the tangents. What'd you do to the tangents? Tangent of A is 4/3, tangent of B is 3/4. Exactly right. We flipped them. Okay, they're just reciprocals. So that's kind of interesting to see, don't you think? Yeah. By the way, we're having a quiz on this next week. All right, so some of you guys aren't taking notes. Some of you guys have your heads down. Not wise. That's all I'm going to say about that. Okay, now let's do something here. Let's do an example. I think we're ready to do an example. It's really what we just finished doing, but example 1. Let's do this. Let's do this. Again, this only works. This SOHCAHTOA thing only works with what kind of triangles? Right triangles. So don't try it with an acute. Don't try it with an obtuse. There's other things that we're going to learn with obtuse and acute triangles, but it's not this. All right. Let's call this ABC. Let's see. Is that what they call it? Yeah. This is right from the book. This is 9, and this is 5. And what they're going to ask you to do is find the values. They say the exact values. I'll show you why in a second they say exact. Find the exact values for the sine, cosine, and tangent of angle A. All right? We could do both of them if we wanted to. But I want to find the sine of angle A. I want to find the cosine of angle A. And I want to find the tangent of angle A. These are considered to be our 3 basic trig ratios. You're going to have a problem in a second. or a couple minutes, that's going to say, give me the 3 basic trig ratios of this triangle, of angle, I should say, of angle A or of angle B. All right? This is what they mean. When they say find the 3 basic trig ratios, this is what I want to do. So I'm going to write down sine of A, cosine of A, tangent of A. All right? All right, let's do the sine of A. Here's A. I'll put a little arc right there. All right? So again, in your head, what is the sine? What over what? So, S-O-H. Opposite over hypotenuse, okay? So let's take angle A, because I'm taking the sine of angle A. Which one is opposite angle A? 5. Which one's the hypotenuse? 9. Good. Let's do the cosine. What's the cosine? What over what is the cosine? No, it's not opposite. It's cos, C-A-H. It's adjacent over hypotenuse. So now, let's find the adjacent. What's the adjacent side? We don't know, do we? Don't know. We'll call it little b, since it's opposite angle B. All right? We don't know, but we can figure it out. How can we figure out? Oh boy, it's not that hard. We've done this a bunch before. Pythagorean theorem, very good. Okay, it's Pythagorean theorem, right, to solve for b. So in order to find the adjacent, okay, we got to do that. It's not. This is not a 45-45. It's not a 30-60-90. Okay, it's just, we don't know what the angle is. All right, so what do? B squared plus what? 5 squared equals, which is 9. 9 squared. Okay, use the numbers. Use the numbers that I have here. Everybody with me on that? Pythagorean theorem. Now, let's keep going. B squared plus what? 25 equals 81. Subtract 25. Okay. It's 50 something. Because you got to borrow from the 8. 50 what? Make that on 11. 11 minus 5 is what? 6. So it's what? 56. But this is not 56. What is it? It's the square root of 56, right? Because we've got to take the square root of both sides. Now, you could simplify that. They do in the book. Normally, I would make my students simplify it, but we haven't really done that a whole lot this year, so I'm not going to make you. I'll just let you keep it square root of 56. Most math teachers would make you simplify it, and I probably should, but we're at the end of the year. I'm just let you keep it like that. So now we should be able to do the cosine, correct? We should be able to do the cosine. So what's the cosine of A? What over what? Adjacent over hypotenuse. Now we know the adjacent. I had to do a little work, but now I know the adjacent, which is the square root of 56, over the hypotenuse, which is 9. Good. See what we did there? All right. The tangent of A. What over what? Opposite over TOA. TOA. Adjacent. Opposite over adjacent. So here's angle A. Which one's opposite angle A? 5. Which one's adjacent to angle A? Square root of 56. Got a little issue with this. What's the little issue that we have? Square root's in the bottom. It's in the denominator. Remember how we do you remember how we have it not be in the bottom?
1 times it by square root.
You got it. Top and bottom, right? All right, so what do we have? The top's super easy. It's just 5 times the square root of 56. What's the bottom going to be? Just plain old 56. That's right. Okay? Now again, you should be able to simplify the square root of 56. I'm not going to do that right now. So if you look in the book, it might be a slightly different answer. But it is an exact value, though. It's just not a simplified exact value. So there you go. There's the sine of A, there's the cosine of A, and there's the tangent of A. You okay with that? So that's not so bad. Let's do another example. Example 2. Another right triangle, because this is used with right triangles. Okay. Now, this is kind of the same, but with a little bit of a twist, all right? So they're not just going to tell you like the sides of this. They're not even going to tell you two sides, you got to find the third. Well, they will eventually, but not at first. Here's what they tell you. Here's what they give you. They tell you that the cosine of A, they actually tell you what the cosine of A is equal to. They don't tell you any of these sides, but they do tell you this, all right? And what they want you to find are the other two trig ratios. So they give you the cosine. What are they going to ask you to find? No, it's not sin. It's the sine of the angle. I'll tell you what. Let's put it down here so I have some room to write. So they're going to ask you for the sine of that angle, and they're going to ask you for the tangent of that angle. All right, so this is what we're trying to find, these two things right here. But this is what they tell you. This is given. All right, they tell you that is true. So where are you going to put angle A? You could put it up top here. You could put it down the bottom. We'll put it right here. And we'll make this B if we wanted to have a B, and we'll make that C. Everybody with me? Now, watch what they give you. This is the little twist. This shouldn't really be that hard to figure out. They say the cosine of A is 3 over 5. So here's angle A. The cosine is what? Adjacent over what? Hypotenuse, right? It's the cos, C-A-H, right? Adjacent over hypotenuse. So check this out. This gives me two of my sides, doesn't it? It gives, what's the adjacent side? That's this bottom one, right? So that's going to be 3. What's the hypotenuse? It's going to be 5. So I can put a 5 right there. You see that? Yep. And now you could figure that. They made it easy for you, made it a Pythagorean triple, okay, which is fine. And so what's BC going to be? This side right here? That's going to be a 4. So now it should be really easy to figure out what the sine and tangent is of this, okay? You guys with your heads down, 1, 2, 3 down, okay? You're having a quiz on this, and you can fail if you want, all right? I don't want you to fail.
They don't want it as bad as I do.
They don't. You're right. You're paying attention. You're taking notes. That's what you should be doing, and that's how you're going to learn. And that's how you're going to learn. All right. All right. We're not debating this. Come on, let's keep going. I was trying to say something nice to you, all right, and then everybody goes ballistic. So hush, pay attention to me. So let's find now what? The sine of angle A. So I've got my 3 sides, so I should be able to find everything. I already got cosine. They told that to me. What's the sine? What over what? It's, what is it? Opposite over hypotenuse, right. So what is the opposite of angle A? 4 over what? 5. Okay, let's get rid of these lines. These lines can be confusing. All right, what about the tangent of angle A? Tangent is what over what? Opposite over adjacent, okay? So what is opposite? 4 over adjacent, which is 3, and that's all they're asking for. That's it. Pretty easy. Agreed? Yeah. Let's see what else I want to do. All right. Stop ratting people out. Just pay attention. If you're on your phone, get off your phone. All right, here we go. Let's do another right triangle, but this is going to be one of our special right triangles. We've dealt with this triangle before. And this doesn't look 30, 60, 90, does it? Yeah, it kind of looks, watch this. These two sides right here are equal to each other. So they're isosceles, that's true. So what are these two angles right here going to give? 45, good. All right, we're going to do kind of the same thing a little bit. You ever look at your calculator? Here, I'll put the calculator up because we're going to use it here in a second anyway. If you're watching this on YouTube, you won't be able to see the calculator. Sorry. I have to do this. Most of your calculator is probably already pre-programmed, but mine, every time I turn it off, I got to change it. So do you see the third line right there where it says radian and degree? I need to make sure that I put it on degrees. See how I put that? See that little flashing bar? Okay, it's on degrees. I hit enter, and now it's in degrees. Make sure your calculator is in degrees. Somebody in my pre-calc class the other day said, Mr. Hamrick, I was putting all the numbers in, I'm getting an error. And I looked at it, I'm like, you're in radians and not in degrees. So make sure that you are in degrees. Okay. You ever see these buttons on your calculator? You got a sine, a what? A cosine, and a tangent, okay? You probably had no idea what those buttons were, but we're going to use those. I've got 5 minutes, 6 minutes, okay? So just watch very carefully. Now, I'm going to do something right here. You're probably not going to understand really why, but if we were to teach this like the whole chapter, you would see why. But I'm going to make that into a 1, all right? So knowing that this is 45, 45, what is this side and this side going to be? How do we figure that out? If I knew this side, I would multiply by square root of 2 to get this, wouldn't I? Okay, but if I know this, what do I do to get this? I divide it by the square root of 2. Let's simplify that. So what's that? I'm going to do this pretty quick. We did it with that square root of 56, didn't we? Okay, I just multiply top and bottom by square root of 2 over 2. Square root of 2 over square root of 2. And this is what I get. So this side right here is the square root of 2 over 2. This side right here is the same exact thing because both these sides are the same. That's a square root of 2 over 2. Now watch. What I want to do is since I know those numbers, and I didn't have to know any trig to do what I just did I? All that stuff is old, okay? We've done that before, okay? But now, watch this. What if I wanted to find the sine of 45 degrees? Now, I could put it into a calculator. Everybody's looking up here. Look up here. Not everybody's looking up here. Nate, put your phone away or I take it. If I see it open or in your hand again, I'm going to take it. Put it in your book bag. Put it in your book bag. It's not in your book bag. Put it in your book bag. I'm going to walk over right this second and take it from you. Thank you. I shouldn't be thanking you because you should have done it a lot faster than that. All right, look up here. I only got a couple minutes. The sine of 45 degrees is equal to what over what? Now, I could put it into a calculator, and we will in a minute or two. Okay, I will put it in a calculator, but I'm going to show you that you can find it, and the calculator answer is going to come out to what we got without a calculator. Sine of 45. So I could use this angle right here. Sine is what over what? What's going on? We're not finished. It's the opposite over the hypotenuse. So what's the opposite of this 45? Square root of 2 over 2. Okay? Over the hypotenuse, which is a 1. Well, anything divided by 1 is just itself, right? So that's the square root of 2 over 2. So what did I just say? The sine of 45 is equal to what? The square root of 2 over 2. All right? Now watch. I want to show you on the calculator that it's true. Let's put the sine of 45. On a calculator like this, I hit sine first and then I hit 45. Now some of you guys might have calculators like the one on my phone that I use all the time. It's just a regular scientific calculator. I would actually hit 45 first and then I would hit what? The sine. Okay, so you got to make sure that you know how your calculator works. Okay, so on this calculator, you hit sine first, then 45, hit enter, and that's my number, 0.707, blah, blah, blah. Now you're like, well, I don't know if it's that. So guess what? Let's put this in, square root of 2 over 2, and see if it's the same thing. What is your guess? Probably is, yeah. So watch. Square root, there's a square root of 2 divided by 2 equals, boom, look at that. So do you agree that the sine of 45 is the square root of 2 over 2? Absolutely. Okay, that's pretty interesting. Let's do one more. I got a couple minutes. Let's go, I could do tangent. I'm not going to. Let's go to this. Let's do a 30, 60, 90 this time. So don't lose me. Come on. I know we've been doing a lot of stuff today. It's taken a while, but hang on. All right, so let's say that's 30 and that's 60. Again, let's make the hypotenuse a 1. There's a reason for that. You don't need to know why right now, but let's just make it a 1. What's the short side? Short side would be half of the hypotenuse, wouldn't it? So that would be a half. Right, let's just write it as a half. Okay? Now, the long side is the square root of 3 times the short side. So this would be the square root of 3 over 2. Okay? So now, what if I asked you what the sine of 30 degrees is? Well, there's your angle. What's the sine? Sine is what over what? Opposite over hypotenuse. So it's going to be what? 1/2 over 1, which is just 1/2. Let's see if that's really true. Let's hit the sine of 30. Oops. Let's do this. The sine of 30. And then, look at that. It's 1/2, isn't it? 0.5. So would you agree? So knowing our little trig stuff, there are these special angles, we can actually figure out what it is. Now, these are just special ones. If this was like 23.7, we can't just do it with a right triangle here. We'd have to put it into a calculator. All right, but that's what it's telling me. It's telling me if I have a triangle, listen to me, listen. What does the sine of 30 mean? That means if I have any triangle with a 30-degree angle in it, any right triangle, that means the opposite over the hypotenuse will always come out to be 0.5. Okay? Let's do the cosine of 30 degrees. What's the cosine of 30 degrees? It's the adjacent over the hypotenuse. Okay? So what would that be? Square root of 3 over 2 over 1. Don't need to put the over 1. So let's see if it really works. Let's see what the cosine of 30 is. It's 0.8660, blah, blah, blah. Okay? Now, how do I know that that's the square root of 3 over 2? Well, let's put the square root of 3 over 2 in. So there's the square root of 3 divided by 2. Let's see what we get. Same thing, isn't it? So do you agree that the cosine of 30 is the square root of 3 over 2?
Yes, sir.
And that's just a little bit of why we would need to use this stuff. Okay? You guys are going to do...
That little bit is a lot. No, it's not.
Okay, you guys are going to do 1 through 16. Okay? So it's section 12.1a. Well, this is probably the only thing I'm going to give you, so it's 12.1. Have a seat. Stop. Why are you guys walking around? The bell is not rung. Just have a seat. I'm doing something here. That's your homework. That is due tomorrow. That is your homework. 1 to 16, section 12.1. You can find the page number. Just flip to section 12 or chapter 12. All right, and it's 1 through 16.